Hi everyone, welcome back to our our Calculus 3 class notes. We are now on page 31 and going over example 28. So in the last page we talked about where the equations of motion for a projectile come from, and here we'll work through an example. So a projectile is fired with an initial speed of 500 meters per second and an angle of elevation of 45 degrees. So that is our alpha here. Since we're talking about meters, we know that we're going to use the gravitational constant to be 9.8 meters per second squared. Our flight time, which we figured out in the past on the previous page, right here, projectile reaches, that's not flight time. My flight time is right here. When the projectile is fired over horizontal ground, the projectile lands when its vertical component equals 0. That time is 2 times nu naught sine of alpha over g. So there's our flight time. So it's 2 times 500 meters per second times the sine of 45 degrees divided by 9.8 meters per second squared, which if you simplify that comes out to be about 72.15 seconds after launch. The range, downrange, how far did it go along the x-axis? We figured the range out to be here. That is nu naught squared divided by g times the sine of 2 alpha. Nu naught squared times the sine of 2 alpha divided by g is 500 meters per second squared times the sine of 90 degrees. 2 alpha, 2 times 45 degrees, divided by 9.8 meters per second squared, or 25,510.2 meters. Now, how high overhead will the projectile be when it is 5 kilometers downrange? So first of all, I want to know where it will be when it's 5 kilometers downrange. Okay, so what is the x location? Well, that's 5,000 meters. So what time does that happen? I'm sorry, that's what we want to figure out, is what time it happens. So that's 500 meters per second times the cosine of 45 degrees times t equals 5 kilometers, the same as 5,000 meters. Since I've worked in meters up here, I got to still work in meters. So that's 5,000 meters. So simplifying that, t is 10 times 2 divided by root 2 seconds, or 10 root 2 seconds. So how high overhead will projectile be is what its y value is at that time. So y at 10 divided by root 2. So remember, the y component is the j component of our position function. So this is where the y component always is in our plane xy plane. So our initial velocity, our initial height was 0. So we don't have an initial height in this example. So we just plug in 10 root 2 into t right as such, and this is what we get after simplifying. So it'll be 4,020 meters high. What is the greatest height reached by the projectile? Well, that's the max height, which we figured out on the previous page also, y max, which is nu naught sine of alpha quantity squared divided by 2g. So 500 times root 2 over 2 squared divided by 2 times 9.8 is 6,377.55 meters.